polynomials day 2. In day 1, we said if it's a monomial times a binomial, you would do distributive property. We did binomial times binomial, like number 1, and we did binomial times trinomial. We also did ones that had 3 things multiplied together, like problem number 3 there below. And so we'll just go through these things one at a time. Now, this particular type of problem is definitely a binomial times a binomial. And one has a plus and one has a minus. Otherwise, they're the same. On these problems, something always happens, and we'll talk about it as we go. So, when you're doing FOIL, you do the first thing in both parentheses. You can write this down. This is 3x, or 6x times 6x, which is 36x squared. They both have an x, that's why it's x squared. When you multiply this one, only one of them has an x. When you multiply this one, only one of them has an x. And then you do the last thing in both parentheses, and you get minus 16. Try to write equal signs every step if you can remember. Now, if it's like this, where one's a plus and one's a minus, otherwise they're the same, these two terms will always add to 0 or combine to 0. So somebody could just do this one and this one only if they knew that was going to happen. That would be okay on that kind of problem. I wouldn't probably get in the habit of that, but it would be correct because those outsides and insides give you 0, and then you just combine like terms. Every answer is in standard form, and that's the answer to that one. So 2 is similar because it's got, you know, the same terms except for one has a plus and one has a minus. But we do have an x squared there. So again, this would be a FOIL problem. First outside, inside, last. If you think you know what you're doing, you can go ahead of me. You know, don't go too far ahead, but you'd multiply these. Now the 3 times 3 is 9. And then sometimes when I write this 4 here, people don't know if I added or multiplied because, you know, 2 times 2 and 2 plus 2 is both 4. But there's 2 x's and 2 x's. That's a total of 4. So I'm actually adding those exponents to get that 4. Okay, then the outsides, the 3 times 7 is 21. The insides, 3 times 7 is 21. One of them's positive, one of them's negative. And then the 2 numbers, make sure you multiply them, don't accidentally add them. You get negative 49. One of the things we said about FOIL is they're either 2 like terms or none. And there's either 2 negatives or none. So I have the 2 negatives. Sometimes there are none. I have 2 like terms. Sometimes there are none. But if you ever have 3 like terms or 3 minus signs, something's wrong. The mathematical term for when you have these being 1 plus and 1 minus, where, you know, the numbers are the same, everything's the same except for that, is called conjugates. So you don't have to know that term, but you'll hear that term in the future, conjugates, where they're the same except for that one thing. Hold on a second. Keep this. Okay, so number 3. We did one like this in the last notes. You have a monomial, a binomial, and a binomial. We said you could distribute the 3x first and then do FOIL. You don't want to distribute the 3x to everything. That would be wrong. The best way to do this problem is to do FOIL first. So I'm actually going to rewrite the 3x and do FOIL. If you could do the FOIL part in your head and add like terms, you could do that. I probably wouldn't do that unless I'm sure I know what I'm doing. But I would do first, outer, inner, last, and then combine like terms. There's really nothing new there, so I kind of did it a little bit fast. Today's notes are not meant to be something that, you know, it's all new. Now I have to do distributive property. This is a 3x. I think in the previous problem it was just a number. Yeah, it was just a -7, but it's just like this problem number 10 that we did in the last notes. So you had to distribute the 3x. when you do distributive property, there's almost never like terms afterwards. If none of these are like terms, none of your answers should be like terms either. So if you do distributive property, then you end up with like terms, I would be suspicious. We did have like terms earlier in the problem, but then none of these are like terms, so none of these are like terms and the problem's over. So 4 is kind of similar, where you have 3 things to multiply. We have a binomial times a binomial times a binomial. We've never done one like this before in class, so this one's new for us, and it's nothing too challenging. You just pick 2 and multiply them. I can multiply these 2 together first, or these 2 together first. I could even multiply these 2 together first. We got to pick 2 and multiply them. What you don't want to do is go like this. X times X times X is X to the third, and 3 times 4 times 2 is negative 24. That's totally wrong. That's not even using any of the rules that we've learned. So you pick 2 and multiply them. I'm going to pick these 2. I like to do it this way better. I'd rather leave that monomial in front. Or excuse me, that binomial in front. So I would do it this way. You can do it different than me. It won't look the same, but the answer should be the same. But if you want to follow along with me, I'm going to do it this way. So first, outer, inner, last. If you're good at this and you could do these like terms in your head and just get a negative 2x from it, you could skip writing that, but I wouldn't do that unless you're sure you know what you're doing. So I did FOIL. I did binomial times binomial. Now I have a binomial times a trinomial, and we did this. And I know, we had a 3-day weekend, and some people might not remember, but we did do this. And my suggestion was, when you do these 6 multiplications, to line up the like terms in columns. So as opposed to writing 6 things horizontally, I'm going to line them up. So I'm going to multiply x times all 3 of these things, which is easy enough because they just all go up by an x. So I just go from 2x's to 3x's, from 1x to 2x, and from no x to 1x. So all these just went up by an x. Then I have to multiply everything by 3. Let me use a different color here. So I'm going times 3 times 3 times 3. And when I multiply by 3, this first one gives me 3x squared. It's a like term with this one, so I lined it up with the one that's like term with. You don't have to do it that way if you don't like that way. If you keep your equal signs organized, it will help you avoid making mistakes, I think. So I did FOIL. Got a binomial times a trinomial, and then I multiply those 6 multiplications, then I add like terms. Any questions about this problem? Okay. For some people, this is stuff they've learned before. For some people, maybe they were really good at FOIL, but maybe haven't done binomial times trinomial. Some people may not have done any of this. Some people are at different stages. Number 5, if you could do the first step right, you're probably going to do it right. If you do the first step wrong, you're probably going to do it wrong. So see if you can remember how we started number 5. The people who do it wrong, they go like square this, and they write x squared plus 1, which is not the right answer. Squaring something means multiplying it by itself. So whenever you are confronted with a square and you're not sure what to do, don't guess. Write it out the long way. Say x plus 1 squared means x plus 1 times x plus 1, which is just another FOIL problem. And again, if this seems like it's review, it kind of is. We've done this in the previous notes. These ones that I wrote, I don't need. I'm not done with the problem, so whether you have them or not doesn't make a difference. This one you obviously do need there. When you have a binomial squared, that's what this is, a binomial, two-term thing squared, you always get three terms. So if you're not getting three terms, it's for sure wrong. The only way we can get a binomial is problems like 1 and 2, where they're almost the same except one's a plus, one's a minus. If these two parentheses are the same, these will never be opposites. So occasionally I'll see somebody who will write this out twice and then cancel these. These are not going to cancel on these squared problems, on these binomial squared problems. You always end up with three terms. And there's your answer. Okay, so 6, it might be fairly obvious what to do first. If when there's a squared, you write it 2 times. When there's a cubed, you write it 3 times. And then it looks just like the problem on above it, problem 4. Problem 4 was 3 binomials. They were all different. This I have 3 binomials. They're all the same. So I do the exact same thing I did on 4. And so you can go ahead of me and start doing it. I'm going to multiply these 2 together first. I'll give you a little time to try this one. So I know there's going to be people who multiply this out without rewriting this, or they don't use equal signs, and I'm just trying to keep you organized, and I would just suggest doing these things. Occasionally people will make mistakes like I just made intentionally. This is a negative 2x, negative 2x, and these are both negative. So negative 2 and negative 2 is negative 4. I'm sorry, is positive 4. I wrote negative 4. See how I have 3 negatives, three minuses, 3 negatives? If you have that, something's wrong. There's never 3. It's either 2 or none. So again, the previous problem, there was no minus signs or negatives. And you could see on this foil, there was 2 negatives. And this foil, there was 2 negatives. There was you can't really see it, but there's 2 negatives. And this one, there's 2 negatives. There's never 1 or 3 on foil specifically. Okay, then I had like terms. Now I have to do these 6 multiplications. And like I said, you should be going ahead of me and doing these. On the binomial times trinomial, you could have more than 2 negatives. You could have more than 2 like terms. There's 6 multiplications. This one should be pretty easy because, like I said, it's just multiplying by x. Everything just has 1 more x in it. This is everything times negative 2, which would multiply by negative 2, obviously, and the x's would stay the same powers. Any questions about this one so far? If you want to try this one where you do the front 2 first, you can. It'll end up being the same. Or if you want to try the one above it in a different order, whatever order you do should end up the same as long as you pick 2 and multiply them. You can read the next one while people are writing this down. So in number 7, you have to find the area. Now, we're going to do problems next chapter where we have to set up a problem like this, where they give us a real life situation and we have to write lengths of sides. And they look like this. They look like binomials. And we'll talk about why. But here we're just practicing, like, if you had binomial sides and it says area, what do? They give you the area formula, which is length times width. This is not going to be a number area, but the area would be multiplying these two. And the order you write them doesn't make a difference. The order of a multiplication could be either way. So length times width, width times length. Doesn't matter which one's which. Sometimes people get confused and they're like, I don't know which one's which. It doesn't matter. They form a right angle. And we learned about that in rectangles. When the two things form a right angle, you got the base and the height, or we call it length times width. Base times height is the same thing. All right, and this is just a FOIL problem. So I'm not going to go into great detail about this because this is yet another FOIL problem, another binomial times binomial. And I know I keep saying this, but I do want people to know when they make mistakes. So one common mistake is people accidentally add those last two for whatever reason. So make sure you multiply them. Make sure you don't have 3 minus signs because that would be wrong. Or 1 minus sign. It's either 2 or none. And then they're not always two like terms. But there's never 3. So if you ever get 3 things that add together, something's wrong. And that would be the expression for the area. So the area would be some, a value if you knew what x was. So if you made up some random number for x and found those to be the length and the width, then plugging that number into this would give you the area. Flip it over when you're ready. Number 8's a multiple choice one, and I put these kind of problems because they do show up on the test. They do show up on the final as multiple choice, and you don't get partial credit for being wrong. Number 8 says which expression is equivalent. Equivalent expressions is basically saying like expand or simplify or see if these are equal. Now, the long way to do this would be to pick a random number and plug it into this, and then plug the same number into all of these. But even that wouldn't be totally convincing because you might just happen to pick a number that makes them both equal and they're not supposed to be. The right way to do it is to do what we've been doing. On this problem, I write x plus 10, I multiply it out. I know for sure one answer it's not going to be, and that's A. A binomial squared is never 2 terms. And that's what they want you to pick. That's what people would typically pick if they did it wrong. Which one do you guys think it is, B, C, or D? Do you know? D. And the more of these you do, the faster you'll get, and eventually be able to do a lot of it in your head. And try to remember that eventually we're going backwards, and we're going to learn how to go backwards. And the better you are going forwards, the more you could see these patterns, the easier it will be to go backwards. So that one is D. Now 9 is kind of different because they have something that you can't multiply out. It's just as x squared minus 4. And they say determine which expression it's equivalent to. Now, as you get better at this chapter, you might be able to do this in your head, okay? But right now, I haven't showed you a way to do it in your head. You'd have to multiply these out. So you do FOIL on each one. So you'd FOIL this, FOIL this, FOIL this. This x minus 2 is the same as x minus 2, x minus 2. So in fact, C and D are the same thing. So if they're the same, you could pretty much guarantee it's not C or D because those are the same. And if you look at A and B, if you remember what I told you, I said that if you have a plus and a minus, where otherwise everything's the same, right? They're both x's or both 2's. that's where you're going to miss that. You're going to have those middle terms add to 0. So when I do FOIL this one, first, outside, inside, last, the outsides and insides add to 0, and that one ends up being the answer. And maybe that wasn't obvious to you, and that's okay. So if it's not obvious to you, you have to do FOIL on all of them. The first one ends up working. If it is obvious to you and you don't need to FOIL them all, then you would just know it's A. If you did FOIL B and C and D, you would get 3 term things for each one. Okay, last problem. Nope, second to last problem, sorry. Number 10. 10, I didn't used to put on the notes, and then it was on the review or on the quiz, and a lot of people didn't know what to do. Because they're like, well, we didn't do any like this. You have a monomial times a binomial, and then a monomial times a binomial added together. And all you do is you do a distributive property, add like terms. So maybe you'd be able to figure this out without an example, but it's not a bad idea to have an example of everything up here. So I would do 2 distributive properties. Distributive property is multiplication, and multiplication comes before addition. So I distribute, and then I add like terms. And then, so you can add like terms and see which answer you think it is if you know. The like terms are here and here. And sometimes these might not have any like terms, but these ones just happen to have like terms paired up that way. When you add these w squareds, you just add the front numbers. That's what you always do when you add like terms. Same thing here, you just add the front numbers, and it's 8w. And that looks like A. You know, you could see somebody writing C. I'm not sure how people would get the other ones. There must be some kind of way to get those. All right, try 11 on your own. It's only a true or false question. You can just write true or false. If you think it's false, you can say what you think it should be equal to. This is about the 5th or 6th binomial square that we've done. For a lot of people, it's counterintuitive that you'd have to write this out and do this. They would just think, oh, just square both these things and that this is true. And that's why I'm doing this over and over again with you, because this is false and you need to know the correct way to do it. You know, if it doesn't have that minus 18x, it is not the same as this. If you plug in a random number for this, let's say you plug in 10. 10's an easy number to do. If I plugged in 10, 10 minus 9 is 1. 1 squared is 1. If I plug 10 into this, I get 181. Those are not anywhere near being equal. So another way to do it is to just pick a random number and plug it in. That's not the way I would suggest doing it, but it should work for every example, and of course it doesn't. If you pick the random number for this and a random number for this thing that we know it's equal to, they will come out the same for each of these. So, you know, you could try that if you like. Okay.